Algebra Half, Lesson 12 is on page 45, prime and composite numbers, and the products of prime numbers. I want you to grab your lined paper in your math binder, and then you're going to be writing these definitions underneath something like the top of my document here, labeled LS or Lesson 12, maybe the page number 45, and write the terms prime number and composite numbers and include my definitions. Pause this video until you've got that done. All right, you're back. You have definitions in your notes for later and for reference. The definition for prime numbers can be found on page 45, and I wrote it the same they did. We call numbers that you can't multiply other whole numbers to become prime, with the exception, of course, of the number itself and 1. An example could be found on the prime numbers chart to the right, and I'll pick the first one, 2. 2's only factors are 2 and 1. Greater than 1, only whole number factors are 1 and that number. How about 3? Again, needs to only be 3 and then 1, so it's prime. Let's get bigger. 43. I challenge you to find any factors of 43 besides 43 and itself. They have to be whole numbers, and you're not going to get it. It's another example of a prime number. Now, composite numbers, I didn't have a better definition than numbers that are not 0. I could probably add or 1, because 1 is also not counted as a prime number. And then it can't be a prime number. So basically, it's all the other numbers besides 0 and 1. So before we move on, the key is that you understand the concept of factors. We keep throwing that term around. What operation, when you use factors, do you think of? Multiplication. And what are the factors in a multiplication problem? For example, 3 times 2 equals, better get that right. What are the factors? Right here. The numbers you multiply together, and that's the product. So, let's show bigger numbers as products of prime numbers. So, as factors being multiplied to become that number. But the spin on that is they cannot be composite numbers that we show. We're showing only prime numbers, products of prime numbers. So the book will give us a composite number like 84. 84 is divisible by, remember your divisibility rules? For sure 2. And we start building a factor tree. Let's just do those right off the bat. A 2 goes into 84. How many times? 42 times. Is 42 prime? No. It ends in 2, which means it's also divisible by 2. Notice, as I build my factor tree, and I don't recall if you've done factor trees, so if you need more work with this and it's not coming right to you, let's talk more in class. But as I build it, if I encounter a factor that is a prime number, I circle and I continue my branch the other direction. It stops at a circle. 2 times what is 42? 21. Is this divisible by any numbers? Now you see why we learned divisibility. Not divisible by 2, not 5, not 10, but 2 plus 3 is, 2 plus 1 is 3. So it's divisible by 3. I recommend putting your prime on the left always, so you just build them all down and you don't have them all scattered all over the place. It could throw you off. Is 7 prime, or can we divide it? No, it's a pretty sizable little prime number. So the answer would be shown as 2 times 2 times 3 times 7 is our answer. 84, a composite number because it's not 0 or 1, and it's not prime, shown as a product of prime numbers. These are all prime, and they're being shown multiplied. We did that using what's called a factor tree. Kind of looks like a tree. Okay? The book shows it another way, and if you like their way or you have a better way, that's fine, as long as your answers come out the same. Last thing I want you to notice how I showed my answer. From least to greatest. Okay? Sorry, my pen's malfunctioning. But, getting bigger. Do that, please. Practice problems A, B, and C. I want you to really nail this. Use a factor tree or a equivalent method to show work and correct answers for practice A, B, and C on page 46.